Hi everyone, welcome to some more robot building with the Civrays InMoov. As I've promised previously, I'm hoping to make some progress on the shoulder. So if you've been following along, you'll know we've been working on the bicep. And then the next challenge is going to be trying to attach this onto the actual robot. I realised to attach this I'm going to need quite a bit more room, a bit more height on the robot, because we've also got the forearm as well to go on here, and it's going to come well below the torso. So as you can see, I've made a bit of a small change. He's now mounted on a stick. It's not very sturdy, but it should do the job. We might have to beef it up a bit when we get, say, both arms and a bit more of the torso. He's going to have quite a bit more weight in him. We might need something a bit stronger, but this should do for now. So the challenge is to get this bicep attached to this shoulder area. So you have this hole here and another one in the back, and eventually when we're finished we'll be mounting an M8 bolt through there, and that'll be the main hinge for the shoulder. Okay, so we have these parts here. They all sit just in there, I believe. So they'll sit just in there, and they'll tilt outwards like that. So there are a few more components to go in between these two parts, so that's basically what we're going to be working on. We should eventually have a tilt on the arm, out like that. Rotation in this direction, so it tilts up towards us, away from us. And then there'll be rotation in the arm this way, which is what we've already done with this servo here. So these are the first few parts of the shoulder. I printed these parts some time ago on an older printer, and the quality wasn't that great. I had difficulty putting the large gear down into the hole. It didn't fit very well. I had to file it out, I had to file this around. It wasn't very nice at all. Since then I've got a new printer, so I thought I'd reprint these parts and see if the quality was any better. And very recently I've just changed my slicing software from Slicer 3 to Cura, and I've found that has really improved the quality of the parts. So these are just straight off the printer, and you can see that gear fits down in the hole with no filing at all. I will just sand it a little bit because it is a little tight, but it would go in there if I pushed it in. I have had it in once, I've taken it out again. That is fitting into the hole with no filing at all, so I'm a lot happier with the quality of these since I've switched to Cura. This is, I believe these parts are piv center, piv gear and piv worm, I believe. I might have that wrong. This is the worm gear just straight after it's come off the printer with all the support attached still. We'll have a better look at this after I've removed the support, but this is a little bit different to the one we used in the bicep. It looks the same, and I thought it was the same, but the one in the bicep didn't actually fit in here. It's actually a little bit longer. Now I've got the correct worm gear. It looks to be the correct length to fit in there. So I just need to break off this support material. Yeah, that's with the support material removed. You can see a couple of little wispy bits on there I'm going to need to just sand off. It does look like it might need a little bit of filing to make that fit in there. It is pretty tight. It's not quite. You could almost force it in, but obviously we want a reasonably loose fit. It's actually catching here. So just there, which is similar to what we had in the bicep. So I'll probably just need a little bit of filing out there. I think the length is a little tight, so maybe just file down the top a little bit to shorten it very slightly. And probably just file out this area here a little bit. It's not quite smooth, and we need just a tiny little bit more clearance on that. So I'm just going to have a little file away at these areas, probably the top of this, inside of here, and perhaps this section here. So the gears are fitting in there now. I can just about rotate this worm gear with two hands, but I think we need that a bit looser than that. It's just a little bit tight at the moment. It will free up a bit once we add the grease, but I just want to be sure it is smooth enough before we start adding grease. So I'll just keep working away at that a little bit more. I've got two more of these HS805BB servos. They'll both need modifying for continuous rotation and to extract the potentiometers. So I'll get that done now. So I'm doing both at the same time. Thought it might just be a little bit quicker. Basically the same procedure as before. We need to just desolder these three joints here. And then with the circuit boards off, we can now get to the potentiometers, which are down in here. So we just remove this one screw, the potentiometer will come out, and then we can just chop these cables off here to remove it. So there you go, you just have to give them a little wiggle and then they come out. So we can just cut these off, keep the wires fairly long on the board, just cut them off fairly close to the potentiometer. So what we have to do now is, before we can put the board back on, we need to get these cables out through the original grommet if possible, or the other alternative is to just file a little piece away to allow them to come out in a similar position. So I've just resoldered these three joints and put the boards back on. I didn't put them through the grommet this time. What I did is I cut the grommets off and I just filed out the square hole a little bit to give us a little bit more room to get the extra cables out. I thought that was just easier than trying to squeeze them through the grommets. So we can put the covers back on. No, we can't put the covers back on. We need to remove this top piece to get access to the gears, because we need to modify the gears. So all we have to do is chop off this lug here, which is basically a stop that stops the servo from turning too far. But if we remove it, then it can rotate continuously, which is what we want. Okay, so these are both modified now. I've put the covers back on and they're ready to go. I'm not going to extend the cables just yet because I want to just get a rough idea where they go and how long the cables need to be. I don't think they need to be very long because I think the potentiometers are fairly close to the servos, but I will just wait and see. So I'm going to assemble together these 4 pieces. These sit on here, and the hole goes towards this side where the space is for the worm gear. We need to put one of those on there, then put the servo holder in there, and then put the other one on the other side. The servo holder has got some support material on it that needs to be removed, so that's here and on the other side here, so they need removing. And there's also support material inside the 4 mounting holes, so that will also need to be removed. So I'll get that support material removed and then get all 4 of these pieces assembled together. So here's that assembly. You can't actually push these joints in too far because they hit that little raised section in there, so you can't push them in any further than that. But that's looking okay. Someone has commented about being able to see the infill in there. That's not because I haven't got enough layers on that, that's because I'm using a semi-transparent plastic, so you can actually see through it. I'm not using that anymore, I've run out of that. I'm now using just normal white, like this bottom piece. So that can tilt. So that's moving freely in there, so that's good. We'll need to put some grease and ball bearings in here, and then I believe we can screw this on that way around. So I've decided I will extend these cables now, just get that little job out of the way. We'll do exactly the same as before, and we'll connect red to the red, white to the yellow, and black to the green. I bought one of these heat shrink assortment kits years ago for previous projects. They come in quite handy. They give you basically a different assortment of different size heat shrinks, already cut up to nice short lengths. So I'm just using the real small stuff. I think that's the 2.0 by 40 millimeters. So this is the 2mm heat shrink adhesive tubing over top of the joints, and then I'm just going to put another piece of 5mm heat shrink over top of the whole thing. So then that's kind of what you end up with. So I think we can screw these servos in now. I can screw the first one into here, I guess. Let's think about this. I think the way I did it before was to attach the servo horn onto the worm gear and then just push this servo onto the servo horn and screw the servo in with these 4 holes here and here. I'll just put that together. So I'm going to try something a little bit different this time. When we built the last one of these, I found the screws were fouling on this edge here. You can see I have just given that a little file, that's why it's a bit dirty down there. But I noticed that this one, it looks extremely tight in that area. and the screw heads were hitting it last time, so I'm going to try putting the screws in the other way round. I'm going to put them in from the bottom of the servo horn and screw them into the piston. I've got these tiny little screws. I'm not sure exactly what size they are, but they're 10mm long. I don't know what size the thread is, but it's about 2mm across the thread. I don't know exactly what they are. They won't tap into the servo holes because they are too small for that, so they'll just fall straight out of there. But I think they will tap into the holes in the piston because they're smaller. So if we're going this way, we won't have the head on the top of the piston like we did last time. And if we have a little bit of screw thread poking through, we can always file it off. I don't know if that's going to work, but I'm going to give that a go. Okay, that's not going to work. I was so pleased with myself there. I thought I'd come up with a really great idea to avoid having the screw heads on this side and fouling on this point here. But that is not going to work because now they foul on the opposite side and they hit on here. So we can't do that. I'm going to have to use bigger screws because these aren't going to tap into the black plastic of the servo horn. So I'm going to have to go back to the number 4 screws. And I really think the head of the screw has really not got any room down in there. But I'll put them in and we'll see what we got. So I've screwed those in properly now. I'm going to have to grind the excess thread off because that is just all going to get in the way in there. So I think I'm going to just chop them off with the Dremel. So it's in there, but it's just suffering the same problem as before. The screw head hits in here. So I'm going to have to try and file out a little bit of the plastic around there. So I've screwed the servo in. I think I used 4 number 6 by 1/2 inch screws. I think these could probably benefit from a little washer on these screws because they're kind of at risk of the head sinking into the quite large notch in the servo. I think a small washer on there would be better. It's not necessary though. We're going to need to connect up the potentiometer again so we can have a little bit of control over the servo. I want to get the servo spinning so I can see if I'm happy with the worm gear, and probably when it's spinning I'll add some grease and it'll carry the grease around. But before I do that I want the potentiometer reconnected. Now again, without going back and double checking the tutorial, I don't know if we're supposed to connect the wires up as they come out or whether we're supposed to reverse the cables. I'm almost certainly going to get this wrong, but I'm just going to connect them up in the way that they came out, and I guess there's a 50-50 gamble whether I'll be right or wrong. So we're going to connect the black to the green and the white to the yellow and the red to the red. I'm going to leave the red on the left as we're looking at this with our wires at the top. The red is on the left. That might be wrong, don't follow me. We'll see later if that's right or wrong. Okay, I'll just quickly try and explain the setup I've got here. I've got a lithium polymer battery as a power supply. That's a 3S battery, so it gives out approximately 11.1 volts. Got that running through a voltage regulator, which I think is bringing us down to it says 4.8 to 9 volts. I think it's probably set up for about 6 volts. So we've got a regulated power supply of 6 volts. That's feeding the Arduino on V in and ground. And then we're also using that same voltage to feed our servo. The red and black wire is the power. And then we're just taking a signal cable from the Arduino pin 10 through to the pulse width modulation connection on the servo, which is the yellow wire. I've programmed the Arduino to just simply command the servo to go to position 90, which is its center. And then on my pot, I've just approximately put that into the center position, powered it up, and that was about right. The servo stayed still. It was buzzing a little bit, but it stayed still. And now if I just turn the potentiometer a little bit, we'll see the servo starts to move in one direction. There's no grease in that. It does sound like it's struggling a little bit. Turn it back to center, it'll stop. And if I turn it the other way, it'll spin in the opposite direction. It's full speed in that direction. Just sounds like it's struggling a little bit. So I think it's loose enough, so I think I'm going to add a little bit of grease. If you get the pot dead in the centre, it will stop. I've gone beyond it, I think. There we go. And if you get it dead in the centre, you don't get any buzzing at all. So I'll just add a little bit of grease. So we've seen this before. I'm just using this white grease. I've just put a little bit in here at the top of the worm gear and a little bit down here at the bottom of the worm gear. And then if we just spin it a little bit, it should kind of drag the grease around. Not convinced if those screws are catching or not. I think it's either the screws catching or this here is too tight. It's not too bad. You just kind of hear it pulsing a bit as it's just struggling a little bit. I think that'll do. It's not going to run continuously when it's actually operating. It's just going to rotate, you know, into the position you've asked it to move to and then stop. So I don't know if we're doing any damage to the servo, if it's working a bit harder than it should be. I think I can go ahead now and install this gear. I might just clean it up a little bit. It looks like there's some rough edges on it, and then we'll pop that in there and we'll add some grease into that. Before we put that in, we have ball bearings to go around here. So I'll just get that ready. So I've just put a little bit of grease around that circle, and then I'm just literally sticking the ball bearings onto the grease. These are 6mm ball bearings. I guess they're some kind of steel. So I just need to continue putting them around. I think the tutorial tells you how many to put in there, but basically just fill it up. So the last one won't quite fit in there. I think I count 26. I'm not sure if that matches what it says on the InMoov site, but the last one just won't fit in. I think as they turn, they'll just sort of space themselves out. It doesn't really matter. I think I need a little bit more grease than that, so I might put a little bit of grease around the top of them, or just possibly put some grease around this gear just before I drop it down. I'm hoping I can drop that down in there and the balls won't fall out, but we'll see. Sorry, I didn't show you before I put it in, but I just put a little bit of grease around the other side of this gear, so that will be sitting on top of the ball bearings. And then I've just popped the gear in, and I've put a little bit of grease in the worm gear, and then I've just put a little bit of grease in all the gaps in the teeth of the gear. When we spin that around, that should just spread everything around. I'm hoping that everything will just hold in there and we won't end up with a real mess. So if we just give it a little spin. Right, I'm stopping that because it's lifting the gear up. I'm going to have to get this spinning off camera. So I'm just putting a tiny little bit of pressure on the gear to stop it from lifting up. Normally the top casing would be on this. Just letting it work the grease around. Okay, I've just put some more grease in it, just again around each gear and a little bit around the worm gear. I think you could put even more in if you wanted to. I haven't got a huge amount of this, so I'm going to go a little bit easy with it. If you have built one of these before, can you, if you wouldn't mind, just leaving a comment and tell me how much grease did you put in? Did you just totally pack it full, or do you just really need a tiny little bit? That would be really helpful. I'm going to pop the lid on now. So we built this assembly earlier, and now that'll just sit on there, and we can screw that down here, 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 and I think there's one more down in there. I think you've got a choice. You can either run M3 nut and bolts all the way through. You can attach a nut into the back. I think what I did previously, I just put self-tapping screws in the 4 of those holes. We probably should have fitted the little potentiometer holder in there first, but we can probably get that in afterwards. So I'll screw that down. Okay, so I have got a small problem. I'm just going to show you it, so if you build one and you get the same issue, if I'm correct, it might help you out. If we just spin this up, you can kind of hear it struggling, and a little tricky to see on the camera, but the whole thing's just sort of slightly vibrating. I think what's happening is the screws, the screw heads, they're actually hitting down in here. Now I filed out the base, but I didn't file out the top piece. So I think they're just catching on the top piece, just in there. I'll probably eventually just wear the plastic away and sort themselves out. But I think we're just making the servo struggle a little bit. You can kind of hear it more than you can see it. I'm kind of tempted to leave it. It's not too bad. It does really want sorting out, but that would involve taking it off. And everything's going to be covered in grease now, and then I'll have to file it out, and the filing's going to get in the grease. It's going to be a pain. I think we'll just leave it unless it proves to be a serious issue. Hopefully I won't burn the servo out. So we're getting there. I guess the next step is to screw the next servo into here. I'm not really following what the tutorial tells us to do. I'm kind of just winging it. I think we've got the next servo to attach into there. I've already extended its cable. We did that earlier. I'll need to just verify if that goes in this way round or this way round. I'm kind of assuming it must go that way, but I'd better double check that. Actually, I must be wrong, because there's a slot here, and presumably that must be for the cables, so it must go this way round. I will just verify it, but with the cable slot at that end, it must go that way around. Got the same problem as before. You can't drop it straight in because of the cables. So you can't just drop it down there. You need to kind of tip it in at an angle, and then it doesn't fit at this end. So I think we're going to have to do the same as what we did in the neck, and just chamfer off this edge on the servo holster. It might be nice if that could be redesigned slightly to have a chamfered edge as standard, so that it just makes it easier to slot the servo in. I don't know if I'm kind of making sense there. The servo has to go in at an angle. It can't drop straight down. So if we just had a little bit more clearance on this edge, that would go in a lot easier. It's kind of an exact fit, and it would work if you could drop it straight down square, but you can't because of the cables. So I think I'm going to have to just take the edge off of that there. Turning my attention back to the torso, I've taken the chest plate off and fitted these two piston base blocks. I filed out these holes just a little bit and just smoothed around these circular pieces, so they rotate reasonably freely. I'm going to put them both in so we can put the chest plate back on, even though we're only building the left shoulder. The other one will be ready for the right shoulder when we eventually get to it. So I should be able to put the chest plate back on now. and then we can go back to the shoulder again. So coming back to the shoulder, I've fitted this servo here. It was a bit tight to get it in. I did chamfer off just inside this edge here. I didn't really have to chamfer it off that much. I gave it a good push and eventually got it in. It did nip the wires a little bit. I probably should have been a bit more careful there. One of the black wires just very slightly split the insulation. What I find really weird about this servo holder is these holes for these screws are quite large. They're even a 4mm bolt just fell straight into them. It wouldn't thread in. So you'd need quite a large screw to fit into there. What I find odd is, why are they different to these ones? These holes are quite small and you can put a self-tapping screw in, yet these holes are quite large, and I couldn't find a screw large enough to screw them in. So I've got a little bit of a different arrangement of screws in here. These ones are thick enough but not really long enough. They're only just gripping in there, and you can see on this side, I'm not really very happy with this, but this screw actually just gripped on the edge, but this one just fell straight out, so I had to put a long one through, all the way through the plastic to get it to grip in there. I just find it really strange that these holes are so large. If they had a smaller hole, you could use the same screws as what we used on the previous servo here. Just very odd. So now that we've got this block in the chest, the piston can screw into that now, so you can see how that's going to work. So I think the next thing we can do is to attach this onto this servo. I think I've got this servo horn somewhere. Here it is. So we'll need to attach the piston onto that servo horn and attach the servo horn to the servo. Once we've got that in, we could offer it in and just see how that's gonna fit in there. So I'll get this attached. So this time I am actually fitting the black screw in the center of the servo to attach the horn onto the servo, and then we'll attach the piston onto the horn. So this is a little premature, but I just wanted to get an idea how this works. I'm quite curious. Similar to the bicep, you can thread this in part of the way just by turning this, and then you need to kind of finish it off by manually turning the servo by hand. I'm going to have to do that off camera. He's starting to feel the weight of his shoulder now pulling him over. Starting to get a little heavy on one side, so we might need to put him back on the stand, although I think even then it's probably going to pull him over. I might need to think of some way how I can counterbalance him to take the weight of this, and this is just the shoulder. Once I get the whole arm on, that is going to be really heavy on one side. So what I've done, and I have no idea if this is correct, so make your own decisions if you're building one yourself. I've screwed that in by hand so that it is almost touching this plate in the center. It's a little difficult to show on the camera, but there is about an 8mm gap in there, so just slightly under 10mm gap. And then what I could do is sort of tip it downwards and inwards, and then you can kind of get these holes here to line up. It kind of feels like you could, let's have a look in there. I'm either very lucky, or it doesn't really matter how much you screw that in. You probably can get the holes to line up anyway. You'll just be tipped out at a different angle. So maybe it doesn't really matter how much you screw that thread in. But I've managed to get the holes to line up, so I'm just going to temporarily pop a bolt in that. I should have mentioned before, I've actually run a drill through here already, an 8mm drill bit through this before I inserted it in. I didn't run the drill through all 3 pieces at once. I ran the drill through this piece, and then I ran it through that piece, and then I ran it through this piece, all separately. Now, an 8mm hole in theory should be the correct fit for an 8mm bolt, but I think because of the length of it and the plastic probably giving a little bit, it was very tight to get the bolt through, so I had to run the drill through a few times just to make sure there was clearance in there. And even now I'm finding it quite difficult to get the bolt through. I'm hoping it's going to be okay. It doesn't matter if it's a little bit tight on these plates. As long as it's loose through the centre, we'll be okay. If it is too tight, I'll have to take the bolt out and open it up a little bit more with the drill. I'm not going super tight on this bolt. I've just done it up just so there's the tiniest of gaps in there. I haven't done it right up to the plate. I think if you over tightened that, you would put too much pressure on this piece. You would pull the 2 plates together, and then it would be too tight for this piece to move. So you do want ever so small amount of gap in between here. I mean, it can be touching, but just not pressed tight. I guess when we put the nut on, if we're worried about the nut coming off, we can use a little bit of Loctite on the nut to stop the nut coming loose. We don't really want to over tighten that. So now that's in theory, I would need to attach a potentiometer, but in theory we could spin that up and see that moving in and out. We need to be very careful though, we've got no mechanical stops, so we'll just manually adjust the potentiometer by hand. We'll do the same trick as before. We'll set the potentiometer roughly in the middle, so it should be stationary when we start. So I've powered him up. Center position is sort of straight up vertical on that position of the potentiometer. So I put it into the center position first, programmed the Arduino to position 90, and that should give us a stationary servo, which it has. I have just tried it off camera first, but I'm going to try and show you this. It's a little tricky to hold it and hold the camera and control this at the same time. But if we just turn the pot just ever so gently, you can see the arm pivoting outwards, and I can move it back inwards. I'm just being very careful, ultra cautious, because I'm not sure where my limits are, how far this can go before it hits something. I'm going to have to look at that very carefully off camera to see, oh, still moving, see how far we can go. I assume it's supposed to come in so that it's vertical. Feels like I'm hitting something. Oh, I'm in there. I don't know what you can see, I can't see much. I don't know if we're actually hitting anything in there. It looks all clear down that side. But I don't think anything is touching in there. It sounded as if there was something getting squashed. The cables are under there, but I don't think they're being squashed. I'm sure somebody will shout out if I'm doing something wrong here. There is a little screw there that could hit the plate on the torso. Kind of, sorry, really difficult to show you. It kind of just clears it actually. It comes in front of the chest plate. So it looks like it's gone all the way in. I'm not sure which way I turn this to get it back out again. Not that way. That way. So that brings us out. And again, I'm being super cautious because I don't know how far out we can come before we hit something. Just going super slow. Stop it there for a second, have a quick look. We're nearly at the end of the thread on the piston, so if we went too far that would actually pop out of there. We're okay at the moment, we can go a little bit more, but we're nearly coming out of that piston base. Let's brave it a little bit more. Here it goes. See the pistons now going inside the base. I've just stopped it there. It's still powered on. I've just found the dead center of the potentiometer to stop the servo. You can just see down in there, you can see the piston is starting to recess into the piston base, so if you went too far it would just come right out of the block. I guess there'll be some other limits once we get the potentiometer mounted on the back here. There's another piece I need to print out, a 3D printed part to take the potentiometer that will mount in there. I'm not exactly sure how that goes, but I'm sure once I get the part it will become clear. We don't need to, it's pretty pointless, but we could power up the other one again and see this rotating again. I've got these two screws in here at the minute. I haven't mentioned these up till now. I've just got them in just purely to hold these nuts in down here. There's two little slots inside there where you fit M3 nuts. They were really tight to get those in. Apologies, I did that off camera. I did manage to get one in, and then on the other one I cheated a little bit. I filed the nut down slightly to get it to fit in, and then I just popped these two screws in just to hold them so they don't fall out. It was quite difficult to get in, so I don't want them to fall out on me. I'm sure they will fall out when I undo these, but I'll deal with that when I come to it. I think I'm going to end the video here. Apologies if you wanted to see a bit more. I will come back to this. I think this video is getting a little bit too long, so I want to end this one here. We've got the shoulder in. It's not quite complete because we need another part on here we haven't seen yet. It's trying to move on me. So we will come back to that. Apologies if you wanted to see everything in this video, but I think this is getting a bit long. We'll cut this short and we will come back to this. The next video will probably be on the hand. I've been working on the hand, and I started recording the video on the hand a long time ago and I never got it finished. I couldn't get the fingers working very well. I didn't want to release the video when it wasn't working properly. I've since taken another look at the hand and reworked it a bit. It's far from perfect, but I think I've got enough to at least show you where I've got to with it. I wanted to get that video done first, and then we'll come back and look at this shoulder, and we'll get hopefully everything connected up. So we'll have the shoulder, we'll have the bicep, we'll have the elbow, the forearm, all the way down to the fingertips. So if you haven't done so already, please subscribe to the channel. I desperately want you to leave some comments, so please leave me some comments. Let me know what you think of this. If I'm doing things wrong, please tell me I'm doing them wrong, so I can get them corrected. If I've said anything that's not correct, let me know so I can get that corrected. Other than that, thanks for watching. Sorry we didn't get a little bit further, but we will come back to this. I'll see you soon.